Okay, in this video I'm going to cover Java arrays. Now, arrays are an older data structure that were around long before Java was around, and because of that, their syntax is a little bit different than normal Java objects, classes, and their syntax is a little different. So this is how they work. You declare what type of object is going to be, or object or primitive is going to be in the array. We'll start with an integer primitive. Then you do a left and right square bracket, nothing in there. Then you give it a name. You supply it. Use a meaningful identifier. Now, if you're declaring this up in the field area, you could just stop there and actually initialize it in the constructor. But to keep things nice and simple, we'll do it all right here. You can also do it this way. You write new, because arrays are objects, so you have to make a new object. And it's a new array of integers, and it has, for our example, 10 elements. Okay? So what that really does is it creates an array of 10 elements. And sometimes I'll draw arrays this way, and sometimes I'll draw arrays sideways. And sometimes I'll start at the bottom with 0, and sometimes I'll start at the top with 0. All depends on what you want to do, or what you're illustrating. But the first position, in this case starting at the top of an array, is always the 0 index, and then the bottom one is, if it's whatever the size of it is, it's size minus 1, so this is the 9 index. So this is really creating an array with 10 spots numbered 0 through 9. Now, because this is an integer array, or primitive, the values are actually stored right in this memory location, which is the size of an integer. The other primitives that you can use besides in an array, the other primitives are double, char, and boolean. And double and int have some variations, different sizes, but we'll forget about those right now. So basically these four types, right? Booleans, chars, doubles, and ints are primitives in their variants. And they are stored, because their size is known, there's no question about their size. They're all exactly the same size. Every double is the same size as every other double in terms of the amount of computer memory it takes up. They can be stored right in this contiguous memory block that the array grabs for itself when it executes the new command, or when this new command is executed by Java, right? It creates a contiguous block of memory. It knows what you're making, so ints, so it just, whatever the size of an int is, it multiplies that times the number of ints, and it grabs that size block of memory. Okay? So how do you put something in one of these and access it? Well, the coolest thing about the array is that you have direct, easy access to all of the elements of the array. So in this case, if we wanted to put something in the 2 position, right, which is the 3rd position, we would do list bracket 2, and this whole thing is like, the terminology is list sub 2 equals, say, 3, right? Now 3 in its binary form obviously would be stored right in that memory location, and so on. So you have immediate access to any of the index positions. If I wanted to get out what was in the 9 position, well, you know how, you can guess how you would do this. You could do system.out.print list sub 9, right? And it goes and it grabs what's over there and it outputs it to the screen. Okay.